Alright, hello geometry students. Welcome to Friday's lesson. New material now. I know we were reviewing on Wednesday and Thursday, but now time for some new material. I am aware that I cannot grade new material and put it in the grade book. I'm sure you've heard all that from your other teachers or from the email that the superintendent sent out. This will not count against your grade if you do not do it. I just want to make sure that we can cover everything we need to cover. So if you want to follow it all the way through, that you can get all the material that you want. If you don't do any of this, it will not count against your grade. You do not have to do any of this. I would recommend it because if you do it, I'm giving you a grade for it. So it will do nothing but boost your grade. So use this time to relax, but also to learn this stuff, to do missing assignments from before, to also boost your grade. Yes. Alright, with that, let's jump right into it. Link to the flip grade question of the day is there. You have already found the YouTube lesson if you're watching this video. I'd like you to pause the video at this point and consider, what is trigonometry? Take your best guess. Where have you heard the word before? Have you ever heard it before? Have you heard it but never heard what it means? What comes to your mind when you hear the word trigonometry? I'd like you to pause the video and do that, and then unpause it, and let's move on to the learning target and success criteria for today. The learning target is that you know what trigonometric ratios are. That won't make any sense right now, but it will after today's lesson. And the success criteria is I can use the tangent ratio to find side length. As far as our social contract word of the day goes, we don't have our social contract to look at, and we are not even all together to pick one. But I would recommend you pick a word to focus on. What do you need right now? Do you need a break? Do you need a snack? Do you need to focus? What word is it that you should focus on for this lesson right now? So think about that, and let's jump right into what we have next. If you would like to pause this video and watch the video in your own browser, I would recommend it. Some of you will just not watch the video and just keep watching this video if I don't play it. So I am actually going to play it because I think that it's the best way to start your trigonometry experience. And in our entry task slide, I asked you to write down what is trigonometry. So I think we should answer that question in the best possible way with a song called Getting Triggy With It.
Good morning, guys. I am so excited because we are finally going to start our unit on trigonometry this morning.
That was loud.
Miles.
Is there any way we can make this more fun or something?
On your mark, ready, set, let's go. Trigonometry, bro, I know you know. I go psycho when I see a triangle. You just can't sit, gotta get tricky with it. That's it, 3 angles, 3 sides. T-R-I-G, all up in my eye. Soka, Toa, will tell you where to go. You just gotta know about H, A, and O. Everybody looking at a glance at the box. The H-Y-P is sitting across. Theta, theta, is after eta, eta. So on it, for the look, I don't mark it. The side you ain't touching is the O-P-P. Making it tricky, we want you to see. Yo, what's that last side you say? It's gotta be the 80J. Get tricky with it. Get tricky with it. Get tricky with it. Get tricky with it.
What? You wanna solve with a trig? Watch your step, you might fall trying to work this gate. Soka, 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 toa. In the middle of the problem, don't know which one, huh? You gotta know which angles and sides that are missing and given in the problem. They're the guides. You can come with me, all these problems I've tried. Heard it's hard, well then somebody lied. It's SOHCAHTOA, helps you to study, so you know when to use each one. If you got the O and HYP, so let's you know sine's the way to go. Let's say now you got the HYP and the ADJ, then cosine's the way, yes, yes, y'all. But there's one more, you got the legs, no hypotenuse,
That makes it tan.
getting tricky with it. Getting tricky with it. Getting tricky with it. Getting tricky with it.
Roll with me right now. If you need a side, you gotta know two things. Okay, let's ride. You need an angle and one of the sides. Issue is, where does X reside? See it up high, that's how you know to multiply. So easy, you get it on your own first try. Trig to the maximum, I'll be axing them. How about the one time you gotta use division? Only if X is down below. X and the angle will switch, you know. Last case, it's angle finding time. So let's get it, trust, the data is the goal, get it alone. Calculators will know when I say go. Take the inverse of the numbers on the right, hit equals and show it off. Now you got it, get tricky with it. Get tricky with it. Get tricky with it. Get tricky with it.
I do believe it is just dancing at this point. Oof. Dancing. Dancing. I'm gonna let it go though. I'm letting it go. Yeah, there we go. Okay. Now that your trigonometry experience can begin, we will head back to our notes now. But you needed to see that. And our final project for Chapter 9 was going to be this very video. We were going to lip sync to this video and create our own music video for it. And now that we are not together, I am very sad, because I don't think we'll be able to do it. If we have time at the end of the year, oh, you best better believe it's coming back. Because I was going to give you 50 points just for dancing and having fun. So you were gonna have 50% right off the bat? Yeah, it was gonna be such good fun. It was gonna be such a good time. We'll find, or we'll see if I can find a way to still make that happen and have y'all send in video clips that I edit together or something. I don't know. But I doubt that we can all be that organized to get together. So, if you really still want to do that, you really still want to make the music video, comment down below. And let me know that you really still want to do this, but otherwise, we'll see if we have time when we get back together, if we get back together as a class. Okay, alright. So, that's what trigonometry is, in a nutshell, in a song nutshell. There is more to trigonometry. You'll learn a lot more about trigonometry next year in Advanced Algebra Trig. But for now, we're going to keep things at a pretty basic level. The first thing you need to do is you need to write this down. So I would recommend pausing the video. Remember that you only need to write down what is inside the red box. The rest we are just going to read together. So pause this, write down the red box, and then let's chat. In the red box, it says trigonometric ratio. So what a trigonometric ratio is, remember it is the length of two sides in a right triangle. So, we have to have a right triangle in order to do this type of trigonometry. Later, you'll learn about some trigonometry that does not require right triangles, but for right now, all trigonometry requires right triangles. So a ratio of the lengths of two sides in a right triangle, remember that a ratio is a fraction. We're comparing two numbers, so we're comparing this side to that side. That's what a ratio is. So the three common trigonometric ratios are sine, cosine, and tangent. Today, we are focusing on tangent, and on Monday, we are focusing on, Monday and Tuesday, we're focusing on sine and cosine. Yes. Okay. Next, you are not going to write this down, we're just going to talk about it, and you will write down the next slide. So, tangent is a trigonometric function, denoted by, remember, when we say theta, we're talking about an acute angle. That's all theta means. Theta is a letter of the Greek alphabet. So we have A, B, C, and the Greek alphabet has alpha, beta, gamma, and so on. It's just a letter of the alphabet. It's like X, but Greek. So if we're looking at the tangent of theta, anytime we use a trigonometric ratio, we're going to look at it with respect to a certain angle. So tangent of this particular angle, theta. And the ratio of that angle will always be the opposite side over the adjacent side. So opposite, we've talked about this, like the hypotenuse is opposite the right angle, this side is opposite theta, and the adjacent side, it is whichever one is right next to theta. So these two sides are both right next to theta, but this one is the hypotenuse. Always the hypotenuse across from the right angle, which means that this one is the adjacent. So when you heard the music video talking about the OPP and the ADJ, that's what they were talking about. ADJ stands for adjacent, and OPP stands for opposite. So the tangent ratio is, we have defined it to be, mathematicians have defined it to be, the tangent of a certain angle is the ratio of the opposite leg to the adjacent leg. And if that doesn't make sense, don't worry about it. We're going to keep talking about it throughout the duration of this lesson. This is what I would like you to write down, because I think it says it. I think it says it a little bit nicer than the last slide. The tangent ratio, if we are looking at a right triangle with an acute angle A, so angle A, which is acute, then the tangent of angle A, which is written as tan A, is defined as follows. Tangent of A is the opposite over the adjacent, which in this case is BC is the opposite, and AC is the adjacent. So this you do need to put in your notes, and I would pause the video and write this down, because this is the main thing that we need to know for today's lesson. And now that you're unpaused, let's move on to our first example, finding tangent ratios. This question wants us to find the tangent of angle S and the tangent of angle R. We are going to write each answer as a fraction and as a decimal, rounded 4 places. That's crazy. We are going to round to 2 decimal places, because 4 is a lot. If you want to do 4, hey, go for it. Go nuts. I'm only going to require 2 decimal places. Okay. So, first thing I'm going to do, I'm going to look at tangent of S. Tangent of angle S, we write it this way. Remember that tangent of any angle, we'll call it theta, is the opposite side over the adjacent side. So, let's color code again. Man, I love color coding. Let's look at angle S first. If I'm looking at angle S, the opposite side is 80 right here. This is the opposite side. Because if I draw an arrow away from angle S, it hits this side. That is the opposite. My hypotenuse is always across from the right angle. So this will never change. This is always where my hypotenuse is at. And my adjacent side is whichever one is left over, basically. So my adjacent, and we can abbreviate if we want. Hypotenuse is abbreviated with HYP, opposite is abbreviated with OPP, and adjacent is abbreviated with the ADJ. So if we want to abbreviate them, that's how we can do it. Wonderful. So tangent of S is opposite over adjacent. So all I'm going to do is I'm going to look at the opposite side as an 80 right here, which means 80's going on top. And the adjacent side as an 18 here. So that's going on the bottom. Ta-da! You have done the first part of this question. We wrote it as a fraction. Apparently that's a word. We wrote it as a fraction. Now we need to write it as a decimal to 2 decimal places. So if I do 80 divided by 18, 80 divided by 18 is 4.44444. So 4.44. If you want to put the repeating symbol, I don't care. But since we're rounding to 2 decimal places, you don't need it. Awesome. So tangent of S is done. We wrote it as a fraction and as a decimal. Beautiful. Next color. Next question. We're going to look at tangent of R now. So now we're looking at this angle. And now this changes. This changes which one is opposite and which one is adjacent. Because if I draw an arrow away from R, oh, now the side I'm hitting is 18. So now the opposite is 18. So if I am looking at the blue, if I'm looking at R, this is now my opposite side. This is still my hypotenuse. This is still my hypotenuse because it's always the side opposite the right angle. But now this isn't my opposite. This is my adjacent. So the angle that you're looking at in this right triangle totally determines what's the adjacent, what's the opposite, but the hypotenuse is always the same. So make sure you are paying extra special attention to the angle, that they're asking you for. If they ask you about S, we're looking at the green. If they ask you about R, we're going to look at the blue. Okay, so now, tangent of R is, it's still opposite over adjacent. That will never change. This will always be constant. But what side is opposite and what side is adjacent, that will change. So the opposite, if we're looking at the blue, the opposite is now 18. And the adjacent, if I'm looking at the blue, is now 80. So now, instead of 80 over 18, I have 18 over 80. So boom, fraction's done. Question is halfway done. And if I put this in my calculator, 18 divided by 80, I get 0.225. But if I'm rounding to 3 decimal places, or excuse me, 2, if I'm rounding to 2 decimal places, then this will just be 0.23. And there you have it. We have found tangent of S, and we have found tangent of R. It wants your answer as a fraction, why do I keep saying that? As a fraction and a decimal, rounded to 2 places. So, key takeaways from here, and let's do it in a different color. Key takeaways are, your hypotenuse is always opposite the right angle. Always. Always. But which side is opposite depends on where your angle is. So if theta is here, the opposite is here, and the adjacent is here. If theta were in the top right corner of that triangle, then the opposite and adjacent would switch. Pay close attention to which angle you are looking at, because it determines which is opposite and which is adjacent. Cool. One more required example, but we have 2 more examples if you're looking at we're going to have one that's optional for bonus questions if you want it. That is the solution, and oh look, yay, we did it right. Okay. Oh yeah, and it even highlights opposite of angle S, opposite of angle R. Very, very important to pay attention to. Okay, next example is to find a leg using tangent. A leg, remember, a leg is a side of a right triangle. That is not the hypotenuse. It does not mean your leg. It does not mean that leg. Okay, we want to find the value of x and round our answer to the nearest tenth. So we're going to use tan. Today is all about tangent. We abbreviate tangent as tan. Tan, tangent, same thing. So remember, tangent of theta is opposite over adjacent. Don't forget that. That's, if you remember one thing from today, remember that. That's important. So, and remember that theta is an angle. This is an angle. So in our case, we are looking at tangent of this angle right here, because it's the only angle that they gave us. So instead of writing theta, I'm going to write 32 degrees. And tangent is actually a function that you give it an angle, you give it the degrees, the measure of an angle, and it will give you a ratio of sides. If you don't know the angle, yeah, never mind. So we are taking tangent of 32 degrees, and we know that that needs to be equal to the opposite over the adjacent. So, a different color now. For this particular triangle, if I am looking at this angle, this of course is my hypotenuse. This side is my opposite because it is across from that angle, which makes this the adjacent. So, back to my formula over here, or my equation over here. Tangent of 32 degrees needs to be equal to the opposite, 11, over the adjacent, which is x. And now, everything is as you'd think it would be. Treat tangent of 32 is just a number. If I put in my calculator, the calculator has a tangent button right, oh, I'm hitting the microphone, right here. Oh, and you can't see it because of the green screen. But your calculator will have a tangent button. All calculators have a tangent button. Even if you go to, like, Google, if you just Google a calculator, Google's calculator will have a tangent. It will have a tangent. If I type in tangent of 32, I get a number. Oh, it's green screening out, but you can kind of see. If I give tangent of 32, that's just a number. All tangent of 32 degrees is it's a number. So you can treat the tangent of 32 degrees, treat it like a number. If I had 5 equals 11 over x, how would you solve this for x? Well, you could put 5 over 1 and just cross multiply. You could do that if you want. Or, we don't like x in the denominator, so we could multiply both sides by x, have 5x equals 11. Oh, you know what to do. You just divide both sides by 5, and then x equals, what, that's 2.2. And there you go, bada bing, bada boom, you're done. It is the same thing, but instead of 5, we have tangent of 32. So, we're going to get rid of all that. That was just for the sake of example. And now, we're going to do the exact same thing. And let me color code. We're going to multiply by x on both sides, because that gets x out of the denominator. You never want x in your denominator. If you're trying to solve for it, it needs to be in the numerator. So now, we have x times tangent of 32 degrees equals 11. And I want to get x by itself. Remember, the goal in solving an equation is to get x by itself. So, to do that, I need to divide by tangent of 32 on both sides of the equation. That cancels those out there. And now, I have x equals, I do not know what 11 divided by tangent of 32 is. So, what I'm going to do is, in your handy-dandy calculator, you just type in 11 divided by that tangent button, 32. Right like that, if you can see it, if it's not green screening out, kind of. 11 divided by tangent of 32. Enter, and look at that. Look at that, 17.6. 17.603. And oh, look at that. Now it says round your answer to the nearest tenth. So, because that's a 0. There we go. Nearest tenth. Bada bing, bada boom. Bob's your uncle. Unless he's not. But this is the right answer, is what I was trying to say. Okay, fantastic. If you have questions, I would recommend just replaying this part of the video again in case I went too fast. But you can always tune on to the live stream, noon to 2 most days. Or at noon to 2 every weekday. Yeah, tune into the live stream, and yes. Those are the required examples for today. The next example that we're going to do is optional, and there will be bonus questions on the homework around it. And all the homework right now is kind of bonus, because I can't require it to be as a grade, so this is like bonus. It's like ultra, super, mega bonus. So, I would recommend doing them, if I were you. Okay. Alright, if we move on, this is going to show you the solution. Yep, which is, yep. And look at that, we were right. Fantastic. Okay. This is an extra example, not required for the homework, so if you do not want to see this, skip ahead a little ways in the video, but why not watch it? You got nothing better to do. And I know you love listening to me talk about math, so up to you whether you want to stay here or not. Not required for homework. Okay. Using tangent in special right triangles. So it says use a special right triangle to find the tangent of a 60-degree angle. Okay, so I am going to start with a special right triangle. We'll have 30 degrees, 60 degrees, and a 90-degree angle. Now, we need to put some numbers on this. Does it matter what numbers we put on this? No, it does not matter. If we were here in person, I would say, you, student, give me a number. And we would just use that number, because it really doesn't matter. All triangles with the same angles are similar. As long as two triangles have the same angle measurements, they are similar. And similar triangles are proportional. So the ratios are going to be the same. The tangent ratio will be the same no matter what number you put on this 30, 60, 90 triangle. It's actually really cool. We can talk more in depth about that on the live stream if you want to. I don't want to go super crazy for this lesson. To make things easiest, remember that the pattern is x, 2x, and x times the square root of 3. So to make our lives easiest, let's just make x 1. Nice small number, not super crazy. Let's just make x 1. And then 2 times x, 2 times 1 is just 2. So my hypotenuse would be 2. This were 1. Oh, that's okay. 1. And then x times the square root of 3, or 1 times the square root of 3, that is just the square root of 3. That's it. If we used 2, then we would have 2, 4, 2 times the square root of 3. You can use whatever number you want. 1 is easiest, I think, because then you don't end up with a number out here in front of your square root of 3. So let's just use 1. Sounds good. And remember that all 30, 60, 90 triangles are similar. So, all proportional. This works out no matter what number you use. Okay, now we want the tangent of a 60-degree angle. So this is the angle we want to look at. So with that in mind, this is always our hypotenuse. If we're looking at 60, this is the opposite side, and this is the adjacent side. And tangent of, well, here. Tangent of theta is always opposite over adjacent. Always. Always, always. So tangent of 60 degrees is equal to the opposite. Opposite is square root of 3 over the adjacent, which is 1. What is the square root of 3 divided by 1? What's anything divided by 1? Just itself. 5 divided by 1, 5. Pi divided by 1, pi. All the same. Or it's, yeah. So tangent of 60 degrees is just the square root of 3. And that's all. That's it. Not so bad. So yeah, there will be bonus questions like this on the homework if you want to. Yes. There might be a fun bonus project that I'll let you do for a bonus test grade too. But it's going to require this example too. So we'll see. We'll see. We'll see. Okay. Moving on. Oh, look at that. We were right. Except we didn't find the decimal version, but that's okay. Alright. Next. Ooh, I forgot! Oh my goodness, I forgot. We had another extra example. This one is still not required for homework, so if you do not want to do it, you do not have to. But if you want to, let's party. You are measuring the height of a spruce tree. You stand 45 feet away from the base of the tree, so that must mean that we are standing right here. We are standing 45 feet away from the base of the tree. You measure the angle of elevation. The angle of elevation is a fancy way of saying if I am standing here, at what angle is it elevated? Elevated means, you know, like if you've heard of elevation, elevation above sea level. If we're 1,000, if our elevation is 1,000 meters, we are 1,000 meters above sea level. So, the angle, if we're standing here, the angle that we look up at the tree is a 59-degree angle. And we want to find the height of the tree to the nearest foot. So this is what we are looking for. This is what we want. We want it. Okay. Yes, on the project that I would have given you for Chapter 9, this would have been bonus. Like if you wrote your own story problem with trig ratios, that would have been bonus. So, today's all about tangent, opposite over adjacent. Don't forget it. So, if we're looking at, and let's color code purple. If we're looking at this 59-degree angle here, H is our opposite side, 45 is our adjacent side, and of course our hypotenuse is always opposite the right angle. So tangent of 59 degrees is equal to the opposite H over the adjacent, which is 45 feet. 45 feet, but whatever. We'll put the units on when we're done. Okay. Now, to get H by itself, I just need to get rid of that fraction. I have H divided by 45. So let's multiply by 45 on both sides. And again, this 45 times tangent of 59 degrees, you just punch that into your handy-dandy calculator. Tangent of 59 degrees. So you're going to punch in just like that, if you can see it, if the green screen isn't being poopy. 45 times tangent of 59. Hit enter. 74.09, oh, 0.89. So we get 74.89 equals h. It wanted us to round to the nearest foot. Oh, can't see that. 74.89. It wants us to round to the nearest foot, and because this is a 0.8, we're going to round up. So the height of the tree is approximately, that's what the squiggly equal sign like this means approximately 75 feet. I encourage you to write your answers to word problems, because word problems are words. I recommend that you write your answers to word problems in words, in a complete sentence. So I would typically write something like the height of the tree is approximately 75 feet. I like to write my answers as words, because if the question is in words. Yeah, okay, yeah, I just said that. Alright. Woohoo! If you had questions, try rewatching that portion of the video. Otherwise, tune into my live stream, 12 to 2 each day, and I can answer your questions there. Alright, that was for sure the last example. And, oh, look at that. Look at that. Fantastic. Oh, interesting. Interesting. Yep. They even checked their answer by using a 30, 60, 90 triangle, so that's very interesting. So yeah, check your answers, never a bad idea. Questions, if you have questions, I just said this, but I'll say it again. If you have questions, tune in to the live stream noon to 2 each day, and yeah, hope to see you there. Your homework, these are the required, remember, required, because I can't require them. But these are the ones that I would recommend at the minimum. This is what I would recommend. If we had had class today, this would have been the required homework. And these questions would have been bonus. These would have been bonus questions for the homework. Remember that I'll still give you points. If you do the homework, I'll still give you the points for it. So, yeah, I'll give you even more points if you do the bonus homework. Okay, and last thing for today. Your lunch. Strength does not come from physical capacity. It comes from an indomitable will. I'm Mahatma Gandhi. So, what this means when it says strength does not come from physical capacity, strength is not just about your muscles. Of course, you can talk about physical strength, you can talk about how much weight you can lift, yada yada. But there's much more to strength than your muscles. Strength also has to do with emotionally. Can you handle something? Mentally, are you strong enough to keep working on a problem when you don't understand? So, strength comes from an indomitable will. It comes from never giving up. So my question to you for this launch is, do you have an indomitable will? Do you have the strength to never give up? Why or why not? And another thing I want you to consider, how could never giving up serve you in life? Would it be a good thing or a bad thing? I'm not saying it's always a good thing. There are some times where it might be a bad thing. I think I can think of an example in my life where never giving up actually was not the right thing to do. And then after answering those questions, do you think it would be a good idea to find a way to give yourself an indomitable will? And be able to say, on these things, I'm never going to give up, and stick to that. And on other things, I'm gonna give up. Yeah, not worth it, and that's fine. Is there a way that you could find out how to do that for yourself? How to stick to something even when it's super hard? I would encourage you to do that. It is a very, very valuable skill in life. Thanks for tuning in. Thanks for listening to the launch. If you have questions, check out the live stream, and I hope to see you there. Bye!